Hello, everybody. It is 1:31 p.m. Central Time on the 15th of April, 2021. It's Thursday here in the United States. Before we get going, I've got a Windows update that just appeared up here in the upper right-hand corner of my screen. And just let me know if my voice sounds okay whenever that thing goes off. Sometimes it slows me down, or sometimes speeds me up. I sound like a chipmunk sometimes. It just doesn't know. So let me know if it sounds okay if you're live on Twitch. And that being said, it's been a few minutes since I've done an update. 3 weeks since actually almost 4 weeks, since I've uploaded over on YouTube. And it's just been a while. And for those of you who are on YouTube, guys, it's a long story. You don't want to hear a bunch of complaints about being shut down, etc. But, oh, man, it's been rough. So let's go ahead and turn on a display capture. And we'll start over here in the West Pacific like we normally used to. Deep earthquakes going on here on our letter D. If you're a new viewer, the letter D stands for deep earthquakes. It's a spot points where we watch for deep earthquakes to take place. And we have several of them placed across the West Pacific, 5 of them, and 1 in South America, 1 all the way over here in the Middle East. And we watch for deep earthquakes to take place because shallower, larger earthquakes tend to follow the deep earthquakes. And let me just show you actually a graphic here. Well, let's see if I even have the graphic. There we go. It's been a minute since I've done any updates. What I think's going on is down below the plates, there's a hammering action coming up out of the magma, out of the asthenosphere, which is an area just below the plates that's semi-melted. But the focus that happens over hundreds of miles focuses in on a very small point, and it can't hammer down into the liquid or the fluid of the magma. It hammers up into the underside of the plate, which then starts a wave action that spreads out and across the plate boundaries. And I'm going to be talking about these plate boundaries for the rest of the update. Here's the USGS map showing where the plate boundaries that are marked are, at least the ones they've mapped. And you can see the edges of the Pacific Plate. You can see the edges of North American Laurentian Plate. You can see the edges going all the way over to Europe and so forth. Now, these are like roads or like a river or rivers. And where we get the deep earthquakes is like where a storm is dropping a lot of rain that's going to flow down the river. So, deep earthquakes matter because shallower, larger earthquakes spread out and away. Then, make note of the waves in the tank here. See how they're all about the same size? And the standing wave is what this is called. Now, I want you to think of these like earthquakes. And each earthquake being like a 4 or a 5 or sometimes just a 3 or a 2. But they're all about the same size as they're spreading through this tank in the laboratory. And the reason I want you to remember all that is because then we see the same sized earthquakes within a hair of a point of each other spread out across vast distances, just like in that tank. But instead of a straight tank, of course, we're dealing with the jagged edges of the plate boundaries. And what you'll see, for instance, is across the West Pacific, all about the same size. So we'll start over here at Sumatra, and we're looking at everything 2.0 and greater. 5.5, 5.1, 5.4, 5.1, 5.3, 5.0, 5.1. Let's go over that again. 5.5, 5.1, 5.4, 5.1, 5.3, 5.1. How about this? 5.4, 5.1, 5.5, 5.1. Do you follow what I'm saying here? And the spread, though, is going out and across thousands of miles following the edges of this. Which really, I want you to think of the waves coming up from down below, and they're just trying to find a wave. Oh, the waves are trying to find a way up through the plate, up, out, and away. And it's going to take the crack in the plate as opposed to the solid, more stable portions of the center plate, that it's going to go around the outside edges. That's exactly what it does. Now, once we get up here, we spread 2 ways. Where on one side, we have a 4.6. The other side, we have a 4.7. You also notice there's 4.3 and 4.4 next to it. Those are earlier earthquakes, but again, 4.6 on one side, 4.7 on the other. One side and the other side of what? Well, you see it. We have 4.6 on one side, 4.7 on the other. It's an equal spread, but it's just a hair less, about a half magnitude less, maybe even almost a full magnitude less than what's going on down here in Indonesia. Now, Indonesia was our warned spot, the spot that I issued the warning, right here. You'll notice it's the one spot where there's no earthquake activity. Now I'm watching. We still have another 2 days to go in the watch for a potential up to 7.0 earthquake. Just strike here, we issued a 7 to 10 day watch when the deep 6 hit here. We had a deep 6 this past week. Not even a week ago. So again, deep earthquake in here, and we watch here at this S-shaped bend of the plate, and we're watching right in between the two sets of current earthquakes, which again, when I issued that warning, these earthquakes weren't here. So it is the halfway point. We're waiting. We got 2 more days to go. The spread's going up towards Japan, and we have an open area south of Japan. Kyushu, here, where the letter V is, and the Izu Ridge, here. Now, those are 2 points along that river that I've told you about several times now. That, again, if this is the flowing river, we're going back up to Japan, up on the north side, and we're going around on the west side. But it's going to re-pool back up here in the middle area in between our current sets of earthquakes. So what's the middle area between the earthquakes on the coast of Japan and the earthquakes down here around the bend now down next to Guam? Well, we have to go around the bend of the plate, and the halfway point brings us somewhere halfway up the Izu Ridge. So halfway up the Izu Ridge is going to be a spot that gets hit, as well as South Japan, going just south of Kyushu. Here, and we have Sakurajima volcano that's been erupting, and Suwanizajima volcano, which has also been erupting. Let's go check the Volcanic Ash Advisory Center and see what's going on there. Might get some pop-up ads, but I don't like turning off the ads on this side. I want them to get as much as they can. They're doing a good service. I don't know who runs it, but man, we use it almost every day. Reventador in Ecuador, Ducono in Indonesia, Fuego in Guatemala, Soufriere in St. Vincent down in the Eastern Caribbean, Sabancaya in Peru, Luotolo's back with a 6,000-foot high blast over in Indonesia. That's a new addition that's not normally on there. Sakurajima, like I said, in Japan. Semeru in Indonesia. Okay, we're lighting up in Indonesia a little bit with Luotolo and Semeru. Mount Sinabung also going, and Mount Katovar just to the east in Papua New Guinea. How many times is that on there? Okay, so that gets us into yesterday, and it matters where the eruptions are. So let's just show you again. In Indonesia is where a bulk of the eruptions are taking place right now, and I would say Indonesia is the bulk of the area that's moving seismically speaking right now in the last 48 hours. On the perimeter over here, Mount Katovar. Then we have Luotolo and Semeru and Mount Sinabung. Okay. Up to the north, Sakurajima is the only one erupting right now, and that's right here smack in the middle in between our 2 sets of earthquakes. We call that a fulcrum point, by the way. When you're a halfway point between 2 areas that are moving. Like the balance point, if you will. Once we go up to the north, this struck last night. Well, like 4 in the morning. I was lurking in chat, and people are like, oh, earthquake in Alaska. Well, the solar a G1? Went up to like a G4 solar event last night, just a coronal stream that came in, coronal hole, strong solar wind, and it starts to buffet the Earth. When we see that buffeting of the Earth, all of a sudden you start to see an increase in earthquake activity. Now, new articles just came out this past week. I'm not going to waste the time showing them to you now, but people are sharing them in chat. I got a link sent to me that scientists have discovered a polar hurricane that happens, they're calling it an electron hurricane. An electron hurricane, a space hurricane too is what they also call it in the article, of electron cascade that they found now that's basically spiraling and coming into the North Pole. They just announced it. Man, you guys want to talk about having something that I've talked about for years be confirmed. That hurricane of electron cascade, and that's what they call it, a hurricane of electron cascade. It's like they watched one of my videos on HAARP or something, right? Anyway, it's going down in the core of the Earth there. North Pole, and I would think that the same thing's happening at the South Pole. How about that? But when there's a huge influx of power, all of a sudden there's earthquake activity. People used to deny that there was a relation anyway. There you go, 5.3 struck right at the tip of the Aleutian Island chain. But isn't that 5.3 the same size as this 5.3? Aren't those two connected on the river? Let's go back over and take a look at the USGS plate boundary map again. Again, we got a 5.3 up here in Alaska. We got a 5.3 down here on the Izu Ridge south of Guam. Are they connected? Yes. Did this 5.3 cause this 5.3? No. It's that this 5.3 all the way down on the Izu Ridge, and this 5.3 all the way up in the Alaskan Aleutian Island chain are both part of this. A standing wave that's spreading out thousands of miles. So it's not that one earthquake's causing the other. It's that both earthquakes are caused by the standing wave that's spreading out from where the deep earthquakes are coming up. Okay, now we watch halfway points. These halfway points we call fulcrum points. So we don't just measure a straight line between the earthquakes in Japan and the earthquake up here in Alaska. We find the halfway point going around the bends of the plate between our current sets of earthquakes. So there's really two halfway points. There's a halfway point between these two, obviously, right where the rings overlap, east of Kamchatka. There's another halfway point right here in the middle of the Kuril Islands. Both are going to get hit. And they will both be hit by something larger than what's on both sides. So on one side we got 4.4, 4.3, and the other side we got a 4.6. That means something bigger is going to be coming in. Something bigger, most likely up by a magnitude at most. So that would put it at 5.6, 5.5 to 5.6. Well, wait, isn't that just like what's striking down here? Yeah, the standing wave is going to be spreading out across all these areas. So it should be a 5.5 to 5.6, striking right in the middle here. And then here, it should also be something in the 5.5 to 5.6 or mid-range 5 level. But it's a much smaller, tighter area where it should be sandwiched in. Then we get over to the east and we have a cluster of small earthquakes on one side and a cluster of large earthquakes on the other. Think of this like an out of balance scale, where you've got more weight on one side and less weight on the other. So it would be tilting to this side, if you will. Well, the middle point between the two is going to get struck, but it should be in about the same magnitude range as what's coming across. All this adds up to like a 3 point something. All these zeros, twos, maybe a 4. And all of this, obviously, we got a 5. So 5 coming across. 4 on one side, 5 on the other. Add them together, it equals 5.04 or 5.304. In other words, it's just the same size. So we should get a new mid-range 5, low-end 5, 5.3 there at the middle point. Another middle point right here. Huge middle point. Twice the distance the United States is across. Right here open with no earthquake activity in the last 36 hours. Looking at 48 hours, it doesn't really add too much more to the area, does it? Now hold up. Right down here, right in the middle, Mount Kadovar. That volcano that hadn't erupted in 1,000 years, or was it 2,000 years? Some huge amount of time. I think it was 1,000 years. And it came back alive last year. Now that's not the middle point, is it? No. The middle point is like right here. Right at the triangular bend in the plate in between our two sets of quakes. But on this side, we got a bunch of deep earthquakes. On this side, we got a bunch of 5s. So it means something bigger should be coming in between here. Something bigger than the combined total of 5,000 miles of 5s and a bunch of deep earthquakes on the other side. So I would put it into the 6 range. Goes up into the mid-range 6, a whole magnitude higher. That goes again to 6.5 level. So wait, 2 days left to go in the warning here for up to a 7. And we're due here now in the middle point for a 6.5. So we have 2 middle points. One, the middle point between all the 5s. They go around the bend of the plate. Just find that middle right there. And then the other middle point, again, between our 2 huge sets of quakes. You have to back it out that far to see it. But right here, Solomon Islands going into Vanuatu. Let's go over to the west, shall we? Go across China, where we don't have anything. Oh, Russia! Niet. Okay, never mind. We're not going to talk Russian. It has been a minute, though. Меня зовут Mikhail Yanich. I've been off on vacation. No. Stress vacation. Here we are, going across an area 2 continents wide with no earthquakes reported in 36 hours. Yeah, that's not suspect. I would look at the halfway point again. Even when they're not reporting quakes, we can still put the halfway point into play. So we have a 4.3 here right at the tip of the arrow. We go all the way down here to Sumatra, and we have a 5.5. How are these two connected? Well, you see the arrows, but let's go back to the USGS plate boundary map again. Look at the red line. So if we're going around the bend, we got an earthquake over here, and we got an earthquake down here. What's the halfway point between the two? It's right here at Myanmar, at the bend in China. And that's where we're going to see a new earthquake break out. Something bigger then a 5.5 or something about the same size. Again, we have the same principle as what I was just talking about up here with Alaska and the Kuril Islands. It takes place here where we've got a bigger earthquake on one side and a smaller on the other, which means about the same size. Again, if we take this 5.5 plus this 4.3, we get 5.543. Do you see how you add that together? They're a whole point less. That takes us a full tenth down, and again, that's pretty easy to add up. So it means a 5.5-ish range earthquake is going to be coming in here. It's the spread again. It's the spread of the same sized activity going across the planet, and in this case now it's 5.5. And it all comes back to where the deep earthquakes were originally hammering up with the deep 6. So a deep 6 hammers up, a bunch of 5.5 spread out, and then in between those 5.5s, 6s pop off. And we're still waiting for the 7, right in the middle of the whole hot mess. Over to Europe we go, but we have to go through the Mideast where we don't have any earthquakes reported out of Iran. This is Iran. We also have Afghanistan on the north side and Pakistan on the south side. I would look in the middle. I would look in the middle on the plate boundary in South Iran, and we have to add up the quakes on both sides. So what do we have on both sides? Well, on one side, over in Greece, 5.1. The other side, over, we already talked about it, 4.3. Take the 5.1 plus the 4.3, we get 5.143. And there is where we're going to see it. So we should see something in the low end 5 to as high as 5.3 right here in the middle. Hope I got that right. Now, let's talk about this. Turkey got hit last week, and I was off just a little bit on location. I had warned central Turkey, and it hit southwest Turkey. Magnitude was spot on. A new 5 came rolling in right at the mouth of the Aegean Sea, right next to the Isle of Rhodes. And you may remember I mentioned the Isle of Rhodes. Well, there we are, 5.1 and 5.3. Put them together, it equals 5.4, but whatever. They're about the same size. The Aegean Sea. Now, people asked me what was going to happen after that when it hit yesterday, and I said, well, few things. Adriatic Sea and Croatia should get hit, and then we should see it go out to the English Channel and go out to the North Mid-Atlantic Ridge up by Iceland. I don't know if any of you were in chat when I did that, but that was again yesterday. Or was it 2 days ago? May have been 2 days ago already. Anyway, whenever this hit, again, this was yesterday, so yesterday, that's when I told the person in chat who asked, watch up by Iceland, because whenever we see Greece go, we see within the same magnitude, within 1 magnitude, it strike out at Iceland. And what happened? We got a 5.4, again, well, hold on, we got to add them together. A 5.1 plus a 5.3 equals 5.4. So we got a 5.4 here, and then what do we get? A 4.4 out here. 1 magnitude drop, just as expected. And I would also expect it to go out to the Azores, or very close to it. So whatever we're seeing out here at Iceland should also come out to the Azores. Let's show you how they're connected on the USGS map again. Well, I see it right there. It's like a highway pointing right to a dead-end T intersection to go to north or south. But what about the rest of Europe? You'll see in Europe, the USGS doesn't have anything, do they? Well, we got the arrows there for a reason, because the flow goes around the cratons, the interior portions of the plate. Craton. Kratos! Kratos! It's the Greek word for something. Anyway, the craton, and going around the outside edge of the center portion of the hardest part of the plate, we see the earthquakes go around the outside edge, and any that go up into the middle go right into the Alps. Dead end into the Alps. If it's a big enough push, sometimes it goes across to the English Channel, and that big push came across this past week. Now, I am off on Croatia. Technically, it hit in Austria right here. That's 200 miles. Croatia's right here, going down into Slovakia and so forth. And again, this is Austria, so can't win them all, guys. Sorry. Now let's go all the way back across over into Central and South America. Now, we're going to go back to the start of the update. The standing wave. The spread of the same-sized earthquakes going across a vast distance, right? Well, hold on. Look. But to see the spread of the wave, you have to back it out this far. Look, now you can see it. The same-sized earthquakes. 4.1, 4.1, 4.6, 4.7. Do you see that? So on the north side, we have a 4.1, a 4.1, and a 4.6. And it's right there. There we go. 4.1, 4.1, 4.6, 4.7. Spreading out across the entire portion of Central America, dead ending into Colombia, where it takes a step down to 4.4. So it's all the same size, where the biggest is in the middle. Another way to look at this is on one side 4.1, 4.1, on the other side 4.4, and in the middle the bigger movement. The wave is building in the middle, in between, but the spacing is perfect, going across the huge distance. Now you're looking at this one right in the middle, right? 5.7. Well, wait a second. Let's trace this. Do you see there's a north and south facing fracture zone here? It's kind of hard to see on my map, but let's go over to the USGS map, where we can see the plate boundaries. Well, there it is. You can even see the notch or jut out of it. Here, do you see that north and south facing line? Well, there it is right here. Comes down, juts out, comes down, goes further, and then you'll see the USGS map has nothing going across the Central Pacific. So on the West Pacific, we got it, and on the East Pacific, we got it, but what's in between? Well, the professionals, I say, oh boy, they say that there's no relation between the earthquakes. But going back down here, you can see the fracture zone carries over and meets up with this giant fracture zone that meets and goes back over across American Samoa, right to where our deep earthquakes are raised high off the globe. Now you'll also notice in between the two there's a line, a dividing line, an undersea mount chain that makes a letter C crescent shape that pretty much cuts the Pacific in half. Now that undersea mount chain makes a C shape or a crescent shape and goes into Peru right here. But we can follow that undersea mount chain back up to the north by northwest, and it meets up with the Hawaiian Island chain that goes and meets up and goes up to Kamchatka. Now, everywhere east of this undersea mount chain, we've got our east and west facing fracture zones. They're almost like super highways going across the Pacific, but they all pretty much dead end into this undersea mount chain. There's only 2 to 3 spots where the fractures come across that, and that's right here in the middle of the screen. You see them. They come across American Samoa and dead end into where that hammering action is coming up from down here. So hammering action comes up from underneath, and then it spreads out and across. And we get a 5.7 going over to the east. We get 5.5s going over to the west. They're within 0.2 magnitude of each other across the planet. But they're related. But it's not that this 5.7 is directly caused by the deep earthquakes. It's the spread of the wave, and when the wave spreads, then it reaches a pinnacle point, I suppose, this is a guess on my part, that it reaches a pinnacle point in the plate, where I think the earthquakes are probably happening at the peak of the wave. It could be happening at the bottom of the wave, at the trough. It could be happening anywhere along the curvature of the wave, but it's still equally spaced. The standing wave, that is. And then the earthquakes are just mimicking that as it spreads out across the planet. Okay, so we get a spread going this way across over to the east, and we get a spread this way going across over to the west. Well, what about down to the south? My New Zealanders. You can put the sheep back up in the stable for a little bit or whatever. You keep them in the barn, the corral. Come in from herding the sheep, guys, and we're going to get into the earthquake. No, I'm joking. Come on. You're New Zealanders. You could take a sheep joke. Lord knows you've heard them before, right? All right. Anyway, down here to the south, in the middle of the catcher's mitt, in the Bay of Plenty, we have a 4.3. Auckland's over on the west side. The thumb of this catcher's mitt position here, it kind of looks like a catcher's mitt. That's why we call it. There's a volcano right in the middle of this, like a ball being caught in a mitt. That's White Island Volcano right here in the middle of the palm of the catcher's mitt. Now we got a 4 coming down into the Bay of Plenty. Anytime I see 4.0 plus in the Bay of Plenty, I would hope that they have canceled the tourist trips out to White Island ever since the disaster that happened a couple of years ago out there. You guys remember what happened? Maybe you don't. I'll remind you. A series of 4s and 5s struck out here in the Bay of Plenty in New Zealand. The volcano there, they take tourists on boats, get off the boats, go into the crater of the active volcano and show it off. It's like privately owned or something. And they were doing this regularly in New Zealand. Now they were out there, they ignored the earthquake activity. They said there was no relation between the earthquakes that were coming in and the volcano there. It's so stupid. Anyway, they had a bunch of people out on the island. The earthquakes had hit just a couple days before. It was a topic of discussion even in my videos, because it's not like we see 5s there all the time. You know, you only get it when you get a big push coming in from the north. Hold on, let me show you the USGS map. The red line again. You get a bunch of deep earthquakes up here, And they start spreading out over to the west and start spreading out over to the east. And they start spreading down to the south. And once you get to the catcher's mitt here, right on the inside edge of the plate boundary, you start seeing earthquakes there. You should pay attention to them. If there's a volcano there that's active, and there's an active volcano. They took a bunch of people out there, they were all out there, and it blew. Buried people, burned them, the whole bit. I don't know how many people died, but it was an insane amount of people. It was like, not acceptable. Even one person is not acceptable. But to have a lot of people out there means they were completely ignoring what was going on there. And I just don't want to see that happen again. So, with the new volcanoes going, we have Mount Katovar, we got Luotolo, we've got the others going. I'm not saying White Island's going to erupt. I'm just saying when you see seismic there, you should pay attention to it. And the reason you have something even coming in here to begin with is because of all the activity up here on the red line coming in from the deep earthquakes that are hammering into your North at Fiji. It's basic 101 physics. You push on something, it spreads through that mass. Okay, South America. Really quick, we can get into South America. This is pretty simple. Again, the halfway points, the middle fulcrum points between our current sets of quakes. On the north side here, we got a 4.4 and a 4.7. Look where the rings overlap. They overlap right here on Ecuador. And in Ecuador, we have Sanjay and Reventador volcanoes, which are both erupting. But I would look for seismic release, something bigger than the 4.7 and 4.4. If we add them together, we get 4.84. Take the 4.7 plus the 4.4. First of all, that takes us up by a point. So a 4.7 plus another 4 equals 4.8. And then add in the 4.4. 4.84. So we watch for an upper 4. Then down to the south, same thing. We have a 4.4 on one side, and we have a 4.3 and a 4.0 on the other. We add them together, it equals like 4.6, 4.7. But right in the middle, we have Sabancaya volcano, which is erupting. Do you think that's coincidence that where the rings overlap here, we have two erupting volcanoes in central Ecuador, and then down here to the south, where the two sets of rings overlap, we have Sabancaya volcano pretty much sandwiched right there. It's not a coincidence. The fulcrum points get pressure. If there's a volcano there, it tends to increase the volcanic activity. Down to the south, it's a giant area, thousands of miles across, but the open middle point of it is right where our arrows point down to the travels underneath point. I'd watch that middle point for a new break to take place, something larger between the 4.6 and the 4.3. Again, we're getting to that 5.0 range. If it's any bigger, don't fault me, no pun intended, but watching there. Hey, how about X marks the spot getting hit? Out here in the middle of the Mid-Atlantic Ridge, just north of Ascension Island. Here's Ascension Island, this little speck of a dot out there. It's a volcano that's risen from the seafloor, but we're right on the Mid-Atlantic Ridge. The red lines again from the USGS. Show it to you out here. All right, out there. But you'll notice there's nothing connecting between those 2 points, is there? At least on the USGS map. But look what we've got. Well, look, hey, we could trace the arrow back. Look where it goes. It goes right to the other earthquake. And wait a second. It's a transfer point across the area. Now, what's in the middle? The middle we have, if we go around the bend of the plate, we have to go up and around and back out. And if we take that curve into account and straighten that out into a straight line, it puts the halfway point somewhere right in here, in the Eastern Caribbean, where La Soufriere volcano has blown its top with two 35,000-foot high blasts over in the Eastern Caribbean. And it's not like we're dealing with multiple tens of thousands of foot high blasts over in the Eastern Caribbean much, is it? So why would the Eastern Caribbean suddenly blow? Well, Soufriere had been building for months, I think, at least a couple months, with small lava flows that had built up into this giant dome. I'm not going to show you the videos because there are copyrights on those videos. Apparently, they copyright their science stuff down there for their use, isn't that, or for reselling to the media. I don't blame them. Although that's kind of shady for a science agency. Anyway, over here on the east side, that's the spot where we had the warning going for seismic activity to increase. Now, this is before there was an eruptive. We've been watching this go on for the last several weeks, if not months, with the spread going over to the Eastern Caribbean. Now, something weird happened. Something really, really weird. Do you see this giant open silent zone across the Caribbean. You see, here's Cuba. Here's Jamaica. Here's Haiti, Dominican Republic. Over on the western side, we got Belize, and go over here to Belize, Honduras, and Guatemala, going out to where the letter V is. Okay, now this middle area right here, again, it's a fulcrum point between our two sets of quakes, right? Let's go over to the USGS map. There's a stair step there. Now, I did an update this week where I issued a warning right here next to Jamaica, east of the stair step, west of Jamaica. I cracked even jokes about me coming down there and being a crazy Midwest U.S. guy. And if you got room for me, you can just put me off away somewhere and you'll never hear from me again unless you need me. I'm coming down to Jamaica. I'm coming to take over. I'm never leaving. I cracked that joke, okay? And the reason I cracked the joke, of course, is I want people to feel comfortable. I want them to get the warning and not feel too threatened by a 4 or a 5 that's going to be coming in. Well, I issued the warning for a 5.0 range. Now, what happened? Well, let's go back and look at the earthquakes over the last week. I don't see anything there. It's completely quiet. It's a miracle. It's gone completely quiet. I guess I just got it wrong. Well, imagine my shock a day ago when I'm 24 hours ago? No, 48 hours ago now. I'm in chat. It's like late, and someone comes in and says, hey, the EMSC has just reported a 6.0 preliminary out here west of Jamaica, out in the ocean on the Cayman Trench. And I was shocked, you know. I mean, they had all the details, they had the coordinates, they had the time, the date, everything, okay. They posted a chat, and nothing appeared on the USGS website. So we sat there and waited, and we were all joking about, like, oh, there just must be, to have the night off. Maybe they have to come into the office to report. They didn't report it. They said it was a mistake. A mistake. Okay, now hold on, because this is about I actually went back and counted. I think this is the 18th time. At first, I thought it was 10 times. No, 18 times in the last 3 years. So this doesn't even count. I stopped counting. We didn't go back to the start of my live stream, which was 6 years ago now. But last 3 years, 18 times, a 6.0 or greater earthquake I issue a warning for in a spot that hardly ever gets hit. And the computer reports the 6 or greater striking, and then they come in and delete it and say it's a mistake. Now, if that's the case, I can forecast mistakes. Yeah, I can just walk into a building, point down the row of cubicles to some business somewhere, point to the 5th cubicle on the right, tell them to stand up, and I can tell them within 3 days, you are going to be injuring your right finger with a stapling accident on your desk. And you down the road, you are going to be tripping over that wire that's going to knock over, you're going to break your ankle. I can do it. Yeah, that's right. Hey, Occam's razor, guys, science. Can I forecast mistakes, or are they deleting earthquakes that are hitting in areas where we're issuing warnings? There's only 2 options at this point. 18 times. I mean, if I flipped a quarter and landed it on its side, on its standing up 18 times, even over a course of 3 years, you would think that I was the quarter flipping master, right? Like I was the expert quarter flipper. So I'm an expert mistake forecaster. Or they're hiding the earthquakes. Those are the options. Can they hide an earthquake out there in the middle of the ocean? Sure. Can they make a phone call or hit an off switch and shut off seismometers around the world? I guess. It seems kind of preposterous, but I guess they can. How else do you hide an earthquake? Or is it a mistake? Come on. I can hear people now. Oh, that's just a mistake. Okay, well then 18 times I forecasted mistakes down to the point. To the location, to the point within 2 days. How could I? It's an impossibility. I'm not the expert mistake forecaster. I'm just basing it upon the middle points between the earthquakes. When an earthquake gets reported there, and it's a noteworthy one, but it's out in the ocean, it's the famous, if a tree falls in the woods and nobody's there to hear it, does it make a sound? Well, that's a trick question. The sound is something that somebody hears. I would propose to you that it generates an audio wave, whether or not there's somebody there to hear it or not. Yes, the tree does generate an audio repercussion in the air, in the woods. The sound is something that somebody hears, so it wouldn't be a sound unless somebody was there to hear it, but it's still generating that audio wave. All right, so that answers the question. Was there an earthquake out there? You bet there was. It was out in the ocean. They hit it. They made a few phone calls, hit a few off switches, and the seismometers around the area that would normally detect a 6 are edited or deleted. And the other seismometers around the world that would normally pick it up are either downgraded, make it, have the computer change it, whatever. Private seismometers? I don't know. We'd have to check. Maybe people's private seismometers show it. But then again, they wouldn't accept it because it's Joe and Joe's private seismometer. It must be a truck driving over the seismometer you see there. Yeah, truck driving by, Dutch, don't you know? Now let's go in here and go look at the continental United States. So before we get into the continental lower 48, we actually have to talk about Alaska again. This past week, there was a 5.5. Sound familiar? Like the rest of the planet now. 5.5 right up here in northeast Alaska, about 100 miles away from Harp. We looked it up. It was really interesting. After that, look what's happened. A series of earthquakes have gone all the way across the United States, including 4s up in the northwest, up in Montana. Here, let's get all the noteworthy sized earthquakes on here and get the smallers out. There we go. So the red colored earthquakes are from the start of the week. The pinkish colored earthquakes are from a few days ago, and the whitish colored earthquakes in the last day. You'll see 4.3 North Texas right at the Oklahoma border. But you'll see this one up here, 3.9. It's right in the Bighorn Mountains, just outside of Yellowstone in Wyoming. Now, both of these earthquakes are connected by a series of 3.2s and 3.0s. Here, actually, let's get the 3s back on there. There we go. 3s and 3.2s that mimic the edge of the North American craton. But to see the edge of the North American craton, I have to turn down the rings a little bit. There we go. Now you'll see it coming out of Montana, going down to Texas, back over into Oklahoma. So why does it matter if this earthquake up here was downgraded? It was originally a 4.3. So we get a 4.3 coming in on the edge of the craton in the Bighorn Mountains. Then we get a 4.3 down here in Texas. They downgrade one, they don't downgrade the other. They're related. But it's not that this 4.3 up here in Wyoming somehow caused this 4.3 down here in Texas at the Oklahoma border. It's that both earthquakes are caused by that inundating, spreading, standing wave that's just taking a path of least resistance and trying to go around the outside edge of the plate as opposed to right through the middle of it. There's a crack or a seam or a weak point where the purple meets the rusty brownish color, and that's where the earthquakes pop off. Now, along that purple edge that I just showed you on the craton diagram, it's drilled from up here all the way down through New Mexico, down through Texas, back up into Oklahoma. All these points are drill points. Now, there are volcanoes next to them, too, to top it all off. The only one that doesn't have a drill point right next to it is down in Mexico. Now, I would like to just look up the biggest of the bunch, the 4.3 in Skellytown, Texas. Skellytown. Even in Skellytown. It's not a skeleton. It's a skeleton. You got to be from Texas to understand that joke. We got skeletons out there. Y'all, hey, come on now. Oh, whoa. Hey, look what we've got. We got ourselves an airport, but that's not what I'm really paying attention to. I'm paying attention to all these pumping operations. There's black gold out in the hills. And Texas tea. There it is. Texas tea. What they do there is they'll mix regular water with a bunch of chemicals and put it down into the ground to break apart the shale to release the gas and oil. And then they'll pump it out under pressure from a different drill point. Oh yeah, look at that. Beautiful. Fracking. And lots of it. Look how many frack points there are. All these little squares. These aren't houses. Every little white square in the ground is a different pumping operation. You see how many there are? It just keeps going and going and going. Here, I'll zoom in and prove it. Because I know there's going to be people who are like, oh, no, Dutch. Those are houses or something. No, they're not. No, every single one of them is a drill point out in the middle of nowhere, and it goes through the farm fields and just picks back up on the other side of the farm. It goes right through the field. I mean, they don't stop for the crops or anything. All right, and so is it any wonder there's a 4.3 there? Look how many drill points there are right on the edge of the craton. And the rest of the craton has been displaced in this giant letter J shape that goes back up to the northwest, of course. So back up in the northwest, let's look at the rest of the earthquakes. And now what I'm going to do here, we're looking at the last 7 days worth of earthquakes. Let's turn off the magnitudes. Turn down the rings a little bit so you can see this. This is 7 days worth of quakes, but even people who've never seen this before should be able to compare the earthquakes going down at least across the central portion of the United States, the mountain states, going up to the East Coast. It matches this perfectly. Again, it's a perfect match, especially up on the East Coast. So there's a spread going on, but you see where it's getting jammed or stopped. It's stopped in the middle of the plate at the N-shaped bend of the New Madrid seismic zone where it gets stuck, but coming across all those 3s and 4s. Now, what I would expect in the next several days, new earthquake on the East Coast, going up to near 4.0. Now, we got a 4 in the Midwest and a bunch of 3s coming across to the New Madrid. Where I live just north of this little N-shaped bend on the New Madrid. I would also expect a swarm on the New Madrid seismic zone. Since it's coming across from the south, you see how the whole southern edge of the craton is inundated with seismic in the last 7 days. It stops right here pretty much, which means there should be a break. Now, I hope I got this right. I think just swarm on the New Madrid, nothing huge, but then the bigger earthquake would be striking up here to the northeast. If I'm wrong, it'll be flip-flopped. It'll be a 4.0 on the New Madrid and a swarm up in the northeast that's small. Where's it all coming from? Let's go back over on the west coast. Turn on the last day's worth of earthquakes. 0.0 and greater. This is just 24 hours worth of earthquakes. We just need to see what's going on so we can get a better idea of what's currently moving. So you'll see, again, that 4.3 right in the middle of the screen is the biggest of the bunch for the whole country at the drill points. Over on the west coast, though, you're going to notice not even a single 0.0 range earthquake reported out of Washington, Oregon at all. Just completely quiet. Yeah, hey, Dutch, it's gone completely quiet up in the northwest. We must just be, it's all good. That's good news. No earthquakes. No. You want to see a series of earthquakes reported up there. If you don't, something's locked and loaded. Now, wait a second. Now what I'm showing you here are tremors. These tremors are little vibrations as the plate shifts. Every little red dot. There's 64 of them as of yesterday on the screen here now. Across Oregon, Southwest Oregon down next to Medford, Northwest Oregon next to Salem, and all the way up at the U.S.-Canada border right north of Victoria at the southeast tip of Vancouver Island. Now let's go back a day. Again, 64 yesterday. Go back to the 13th. 147. But they're all centered down in southwest Oregon. Now let's compare. Look at this. Here's the Juan de Fuca fracture zone out in the ocean off the west coast of the United States. Now there's an arrow pointing into the little tremors. That arrow is actually mimicked. You can see it on the plate itself here. This is the Juan de Fuca. So like a giant arrow pointing to us, the spot that's moving, it's shifting here. But really, those little red dots that I just showed you, these are up above this. Think of this down below these. And this is pushing up or pointing up into these. So this pinnacle point corresponds with this up above it on land. And the other way we could look at this is actually to turn this at an angle. Come back in. There we go. So think of this down below this. And so this is pointing up into North America. And so while this is vibrating here on land, the tension and stress and the push is coming from out in the ocean. Why are there no earthquakes reported? Well, let's go back another day, shall we? Let's go back to the 12th. 3 days ago. 165. But again, you see the spot that's pushing. It's the southern arm of the Juan de Fuca on land, though. Go back to the 13th, you're going to, or 12th or 11th. It's going to start to go up in the number. So we get back to like the 10th, 442, 400 instead of 100. So we've dropped off in the actual number of tremors, but the area has spread out. This happens over and over again this way. You'll see hundreds in one spot, and then it'll spread out, and the number of tremors will start to diminish. But the area has increased. So while the number of tremors has decreased, the size of the area that's moving has increased, And then what we start to see is it transfers. And we see more red dots start to appear in other spots as it spreads out across the whole area. But guess what? It doesn't just stop there. It doesn't just spread out across this area. It goes down to the south and over to the east. The Craton again. And if it goes down to the south and over to the east, look at the earthquakes in the last day. This is the 24-hour feed, right? Let's just make sure. Yeah, make sure. Hit apply. 24 hours time. Around the area on the northwest. All this is moving in Washington, Oregon, and Vancouver Island. And then around it, a bunch of earthquakes break out and spread out and away from it. How did the professionals miss this for so many years, man? Something's up. Something's wrong, man. Guys, there's something wrong with the world. They missed this somehow. And they missed this giant arrow shape that takes place almost every week with a series of earthquakes that come out of California, go across Utah, focus in on an arrow-like point, and go into the edge of the Craton this way. And that's exactly what's going on here across Utah. By the way, the spots in Utah, drill point here, volcano down here, and up to the north, parallel to a bunker facility on the Wasatch Fault. Isn't that wonderful? But no earthquakes up in Yellowstone itself, in the park. We were in the park last week with a bunch of earthquakes. Now we only have a handful. That handful of earthquakes, I think, is going to increase big time. Why? Because all this just moved. Washington and Oregon. And with Washington and Oregon moving, we would expect within the next day or two to see a new increase on the northwest edge of the Craton. Look at the edge of the Craton going down through Idaho and down through Montana. Where does it go? It goes right through the middle of Yellowstone Park. Do you think that's a coincidence? Obviously, Yellowstone has formed on the edge of the deformed edge of the purple part, where it meets the rusty brownish part. But follow the purple part out to California, the deformed part. And look where it goes. It goes right over the California-Nevada border, where the other supervolcano is, Mono Lake. So 2 supervolcanoes have formed on the edges of the deformed Craton. Clearly, there's a weak point on the edges of the deformed Craton that's allowing for the volcanoes to form and for the seismic to spread out across it. Somehow they missed all this. Again, it's crazy. It's awesome for me, though. Oh my God, it's so awesome for me. Bad for them, good for me. I'm not bragging, I'm just saying, that's weird. Because I'm a high school graduate. I mean, yeah, maybe I'm like some kind of Rain Man for earthquakes or something, but other than that, I think I'm a normal guy. Well, normal's relative. Never mind. Okay, let's go into Northern California and start. Up in Northeast California, 1.6 at Viola. Now, there's a volcano here. I'm already going to tell you. It's called Mount Lassen. It erupted about 100 years ago. It's a stratovolcano. It's well known. People know about this volcano, so it's nothing questionable or anything. Lake Almanor is where we're going in right next to. Turn on my volcano place marks too. It just froze Google Earth. Got so many place marks now. There we are. See all the volcanoes there? And there's Mount Lassen. Oh wait, there's Mount Lassen. Right next to it here. So, close enough for me. Again, we're just a hop, skip, and a jump from the stratovolcano, but I mean, you could say we are directly at La Tour Butte, which is an andesitic lava cone northwest of Lassen National Park. It was probably active 1 to 2 million years ago. Yes, 1 to 2 million years ago. La Tour Butte. Now, you guys may remember a few years ago there was a series of earthquakes that broke out around La Tour Butte going down here to Inskip Volcanic Buttes. Following that, a bunch of fires broke out right around the area. These hot spots, which I didn't know about at the time, started to appear the second time this happened. Yeah, it's happened twice where we've had a series of earthquakes and hot spots break out here, then a bunch of fires within a short period of time. I mean, is it going to happen again? I don't know. Stack of earthquakes here, these are all small. You'll see, they're all zeros, ones, with a couple twos mixed in, but think of this like the roll of a snare drum. I use this analogy all the time. You can either hit the snare drum hard and get a heavy roll, or you can just slightly roll on it. Well, that's what's going on right now. This is just a slight roll of the drum, not hitting hard. The location, Clear Lake Volcano, the geysers of California, Geyserville. Let's go put the coordinates in and show it to you. The volcanic field. Now, they drilled into this thing to get steam. They inject your poo down into the ground and steam it off to get the steam to turn the turbines. They take human sewage and put it into the ground at this volcanic field. Yes. Nothing could go wrong there. Joe versus the volcano, literally, I made that joke before. It's still cracking me up. I'm cracking my own jokes and laughing at them. That is a funny joke. Okay. But the number of earthquakes there. So the frequency, the number of earthquakes is going up at Clear Lake now. The power, not so much so. The amplitude behind it, the magnitude. So while the frequency, the number of earthquakes is increasing, the power isn't. But why? Well, for the same reason that the number of earthquakes, the frequency up here is low. We're waiting for this to release out. It already released a single 4 over to the Midwest, goes over to the east into the Midwest. A line of earthquakes going across the Bay Area where there's a huge cluster now starting to break out. Milpitas. I am Leonidas from Milpitas. Oh, yeah, guard the gap with the 300 hippies? Is that what's going on there in south of the Bay Area? It's 300 hippies. They form their own thing like 300, but they, yeah, okay, anyway. Where are we? We are right at a reservoir? Is that what this is? Looks to me like they have a giant dam reservoir of some kind here. What is this? Man, that's a heck of a damn structure. Is there some kind of electrical generation going on here? You'd think there would be. Okay, well, there's not. At least as far as I can see, there's no electrical generation there. Let's see where the actual quake is coming in parallel to. Oh, wait. We're right next to Mount Diablo, of course. Oh, here, hold on. Let's go over and click on this. We have to go into the USGS map. Here's Mount Diablo State Park right there. We are just south of it. We're on the San Andreas coming off the Hayward Fault, which, let's go over and take a look at the USGS map again for the fault zone map and the plate boundary map. Bay Area, listen up, guys. You see these thin red lines right here? That's the Hayward Fault, comes down and meets up with the San Andreas. The thick red line is the San Andreas. Now, earthquakes were happening out here. Again, going out into the ocean right along the San Gregorio Fault a few days ago. You don't see them out there now, right? You see one earthquake out there on the peninsula now, but the spread has gone down to the east by southeast, and it's focused in south of Mount Diablo on the Hayward Fault, where the Hayward meets the San Andreas. What does that mean? It means we're going to see an earthquake in Northern California. That's what's going to happen here. Look, all this is shifting up here in Washington and Oregon. It's dropped off over here to over to the east. It's dropped off down to the south with the size, but the number is starting to increase on the San Andreas, going down at least into the Bay Area. Let's go back over and look on the red line map. Coming down out of the Juan de Fuca, and it's stopping right in here. Look where it all stops. It's kind of a juncture point. It's kind of locked right now. Few smaller earthquakes carrying on down to the south, but it's literally just a handful, two earthquakes going down to the south. So I would look where it's locked between our current sets of earthquakes. That puts us into, let's see, we have two sets, two middle points. One here southeast of Monterey Bay, the other in the actual Bay Area. You could arguably say there's a third open area in between Clear Lake and the Bay Area. However, this is a drill point. Again, that's the geothermal pumping operations. So I would think, again, that man-made point as opposed to the natural earthquake points. We watch between the natural earthquake points. Over to the east, the number of earthquakes has dramatically dropped off as well. And we're at the supervolcano right at the California-Nevada border, on the edge of the craton where the purple meets the green. Do you see that? So the number of earthquakes here. Now, the weirdest thing, guys, somebody sent me a map of some guy who was like, claimed to be a time traveler or something. Oh, dude, I love the stuff people send to me, man. Anyway, some guy claimed that like some U.S. Navy map or something. What's his name? Anyway, they show that they say in the year 2020 to 2025, this guy like came up with this in the 1940s, that there would be something that happens that causes all of California to fall in the ocean. And I do not believe this. Okay, I'm just stating that. But the map shows the cutoff point coming right down in between the two at the California-Nevada border. And this is before they knew about the supervolcano there and before they knew about the potential fault that is there, etc. But I just was mind blown to see it. I'm like, wow, that goes right over. And then the line goes down across Ridgecrest and cuts over following the edge of the craton, basically. But this is all before anybody knew about any of that. This is like the 1940s and 1950s. Or maybe they did know. Hold on. Maybe they did know about all of this all the way back then, and they've been hiding it all that time, and that's why they hate me so much. Oh, no. Did I just find like a 1950s discovery and just like that they hid? Let's go over into Nevada. Speaking of 1950s, we have a surface earthquake over here in South Nevada. Let's go take a look and see where we are. One surface earthquake, small, but still it's there. Oh, wow. Hold on. I know where we are. Anybody familiar with the area around here? How about all of this? This is a place called Doomtown. They blew it away in the 1950s with nukes. And these are all underground nuclear test sites that they were doing up until at least the 1980s. You know what? Hold on. Let me get some more information on this. Let's see. We've got our Google Earth gallery. There we are. We should be able to see all the nuke test site information on some of these. U.S. nuke Operation Parrot, 1.3 kilotons on December 16th, 1964. Just one of hundreds that are there in the valley, and they're spread out all the way around the location. This earthquake coming in just to the east, we've got Area 51 just to the east. So Area 51 is right here. And down to the south, we have a tank test range, which I don't know if we'll be able to see. I don't know if they'll have any tanks out there in this imagery. You can see that where they do a little bit of the bombing. Okay. And there's more over to the east. So, I mean, again, there's no question about this. So you guys can go check that out if you need to on the military test sites. I'm not saying that that's what they're doing, but a 1.2 on a surface right there next to Area 51 in the tank test range points to me that there might be an explosion that just didn't get listed as an explosion. Now, some people bringing this up, a Ridgecrest down here, this line of earthquakes that goes down across the Owens Valley and dead ends into the Garlock. Well, the number of earthquakes there dropped off, just like the number of earthquakes at the California-Nevada border, just like the number of earthquakes going down the coast. The number of earthquakes is low frequency, and low amplitude, low power. So not only is it low in the number of earthquakes, but it's also low in the power behind it. Yeah, that's starting to make me a little skeptical because, again, with this all moving, I would think we're going to have a new break in Northern California. Oh, I didn't tell you how big. I would say it's going to be in the 5 range. How do I come to that determination? The way I come to the determination on the west coast of the United States, I weigh all the earthquakes all the way around the planet, look and see what's striking over the last day, 2 days, 3 days, and then I look and see what's missing on the west coast. I find the halfway point between the current sets of earthquakes, and that's the new spot to watch, which means off the coast, Washington, Vancouver, 5-point-something earthquake, let's just put it at 5.1, since that's what's spreading around at least up to Alaska. Okay. 24 hours worth of quakes, let's go down to the south, down into central and southern California. So, Owens Valley, Ridgecrest, number of earthquakes, low. The power behind it, low. You're going to watch it all increase. You should see the number of earthquakes just go through the roof. It should just double or triple in the next few days. So, swarms of earthquakes will first come in, letting you know something's coming your way. And then when the 5 breaks out here on the northwest, if it strikes on land, they'll probably report it. If it strikes out in the ocean, they'll do what they did to the 6 down here in the Caribbean. They cannot have me correct. They just can't. And I'm serious. Guys, there's people like, oh, Dutch, how do you know that they're worried about you? Dude, the USGS issued a public statement about me on Twitter. I had to call them to get it removed. I'm the only U.S. citizen to ever be named by a science agency at all about anything ever. So, yeah, they're aware of it, and they were trying to stop it. They said, I got a sticker printed. It was on July 17th, 2018, on the USGS public Twitter. They said, quote, Dutch Sense is not qualified to be interpreting earthquake or volcanic activity, and any claim made by the account to predict activity are false. Any claims made by the account to predict activity are false. USGS, July 17th, 2018. I had to call them and get that removed. So yes, they are aware, and yes, they would totally hide an earthquake to save their own asses from being wrong. You got to understand, they said not only that earthquakes were not related to each other, they said there was no way anybody could forecast, and no one has ever demonstrated any ability to be able to forecast. Well, I sent them the method, and they said they did not want to test it. So, they don't want to test it. They're issuing statements about me, and earthquakes are striking in areas where I'm issuing warnings. Rare large earthquakes, they're 6.0. I mean, it's not exactly huge, but... And so if an earthquake strikes out in the ocean, out off the coast, do they report it? They hide it from the public, usually. They hide 4s and 5s out in the ocean. Unless somebody says something and makes a big stink about it, then they feel the public pressure. People start to say... Like, for instance, let me just ask you. Look, up until I came along, there was 4s and 5s that happened every week out there. And then I came along, got into it with the people who run the network up here. By the way, they came after me too. The people who run the network up in the Northwest, the Pacific Northwest Seismic Network, their director, the director of the Pacific Northwest Seismic Network, who's now retired, came after me personally, tried to get my fundraisers shut down. He's the professor. So, anyway, he said a few years ago, when he first encountered me, he said, forecasting 4s and 5s and 6s out in the ocean out here is like shooting fish in a barrel. They happen every week. Well, I started issuing forecasts for it, and all of a sudden, the earthquakes just stopped. But guess what didn't stop? The flow that happens from the earthquakes out in the ocean that we used to see out here in the ocean, we still see on land. It's just that they're not reporting the earthquakes out in the ocean. Sorry, I hate to inconvenient truth, no pun intended. Southern California, Mojave Desert. Let's go out and take a look, because I'm thinking that this might be a blast of some kind. Well, it is. How could I know? I must be psychic. Boron, California, kind of let you know what they're doing there. They've got huge quarry there where they're extracting minerals out of the ground. Let's go over on the west. What about this one? Another quarry blast. And this is coming from another quarry right next to the other one, and just like the other one. So we'll ignore those two earthquakes out in the Mojave, but we can't ignore the line of earthquakes coming out of Ridgecrest, pointing down to the Mojave. We also cannot ignore the number of earthquakes dropping off in Southern California. I would look at it like this. The flow into California, if there was a faucet that was turned on, it's been turned off. But have you guys ever turned off a hose, like garden hose, but you still leave it on coming from the house? You see how it builds up with pressure in that garden hose, starts to spray out a little bit from any loose seams that are in the hose or where the hose meets with threading into your spigot, right? The building pressure that happens inside that hose when it's still on, but you shut off or block the flow. I would think that that's kind of what's going on right now. And that spray out, if you will, that comes out the seams is exactly what we're seeing here right now, going over to the edge of the craton. But that would mean up here, that's where it's turned off. That's where it's locked and loaded. That's where I would expect the release to happen. A new break, which then releases out and goes out into the plate. But again, they don't want to show you the earthquakes out in the ocean because they don't want you to see the relation between the spread going across the plate. Why don't they want you to see that? Because they said it couldn't be done. It didn't happen, and they made statements and put it in writing. They put it in writing. Oh, man. No wonder they're freaking out so hard. Anyway. So, spreads of earthquakes going across the craton. That's one of my biggest discoveries. Not just North American craton. Every craton. That's why we have arrows going across areas that the USGS quite literally doesn't have anything on their map for. So, for instance, Eastern Europe or the United States East Coast or the Midwest. They only have the plate boundaries on the West Coast. They don't mark the craton edges. You know why? They said there was no relation of earthquakes going across the craton. And I tried to show them, including the professor that was attacking me from the Pacific Northwest, and I showed him years worth of examples, and he said it must just be chance. He couldn't possibly be wrong. It must just be chance. That was years ago. The craton is being displaced, not just North America. All cratons are being displaced, and the earthquakes are following those craton edges. It's a huge discovery that there's a flow going across the planet and that the earthquake magnitudes are related to each other. Try to show it to them and they all freak out and try to shut you down? Yeah, I don't know. What would you guys think? What if it was you? You discover something where you see there's a relation between earthquakes going across. You document it and plot it out and show it on a map and everything. You try to show the people who are in charge, and they try to shut you down. Start making fun of you and call you names and stuff. What do you do? Well, first of all, you're right. Secondly, if you're into any kind of truth or science, you'll keep pushing no matter what. It doesn't matter how many eggheads said it couldn't be done. And you try to smack them down a little bit along the way because, hey, it's like a big discovery or something. So, just saying, word up and much love. This is my first update in a month. Why have I been gone for a month? Well, let's just say I'm not exactly welcome online in many places because of the discoveries I made. Make all these smart people who went to college and spent hundreds of thousands of dollars and have a lot of prestige. Make them all look foolish, while me, the high school graduate, wearing some vaporwave clothes and staying here at my house on the lake, somehow look better than them. And I don't know, I don't want to. I didn't try to do that. It was just an unintentional series of discoveries. I'm just shocked that people would ignore the discoveries to propone themselves. You know what I mean? Like, at this point, there is no denying it. If you want to know how to forecast an earthquake specifically, I have published step-by-step directions explaining in detail how to copy the method. I'm not trying to sit on top of this and make a buck for myself or make a name. I'm Dutch Sense. Everybody else wanted to dox me and find my real name. I would have been happy just to remain Mr. Anonymous Dutch Sense. No, it's not about me, although I am the unlucky S.O. whatever who just found it, S.O.B. But my mom's not a B. But I'm the unlucky dude who found it. And it certainly has not been fun. When you find something that conflicts with everything that the professionals said and did, and, you'd think it would be a good thing. It will be when I'm older or when I'm gone, guys. The day I'm out of here, the day I pass away, there's going to be, this guy figured out a way to... Yeah, that's how they roll. I will be back if anything else goes down. Now, before we go, I want to take the time to remind everybody, especially if you're new, everything that I've told you. So we're looking for a 7 over in Indonesia, a 6.5. I mean, these are big earthquakes. Don't be scared. It's the one thing you shouldn't be. You should be prepared. So don't be scared. Be prepared. And it doesn't remove the fear of the earthquake so much. So, you can still be worried about an earthquake hitting. And certainly if the earthquake hits, I would think that that's probably a pretty alarming situation. It's going to make your adrenaline run, your heart beat fast, and you're going to be scared. But it can remove some of that anxiousness by seeing what's going on around the planet and what's coming your way. If you lived on a river, you would pay attention to the storms that happen upstream, wouldn't you? Right? You live right along a river. You got a big storm that's upriver, putting a lot of rain on the river. You know the river's going to flood. Right? You aren't totally caught off guard by it if you live along the river. So think of it like that. You pay attention to the flow that's going along the river. And if you live along that path, you pay attention to it as it comes your way. That way, when it arrives, you're not totally caught off guard. You knew to expect it, kind of like expecting the weather. So I'm just doing that. I'm hoping that people will use the info and spread it. Again, if you want to use the method, I've already put out step-by-step directions. See, over the past, people that claimed to be able to do earthquake prediction, they called it prediction, like crystal ball, like knowing date and time and exactly all that info. But the people who were doing the earthquake prediction hoarded and sat on top of their methods. You know, they want to cash in on it. So, to cash in on it, you have to sit on top of it. You can't publish how to do it. You can't tell people how to do it because then somebody could take it from you and you don't make anything on it, right? Well, I published everything. So there's no debate. I tried to give it to the professionals, and they said they didn't want to test it. And that's how I knew I was right. And that's how we're going to end this update. You guys, much love. Be safe. I'll be back. We're going to record this and put it over on YouTube. First video in a month. Peace out.